Hello everyone, let's tackle the hexadecimal system once and for all. Okay, let's have a look at it, what it does, what it is, and how to start with it. Okay, how to get started with it. So to think about hexadecimal, start thinking about what was before hexadecimal. Okay, what we had. Okay, we have this imperial to metric conversion table, for example. Everyone knows it, everyone sees it, no one says, oh, it's so confusing. And everyone says, woo. Is there, 1 mile is 1.6 kilometers. 1 pint is 568 millimeters. And everyone accepts it. You just convert from one system to another. Your imperial unit is a system, the imperial system, the metric system. And then you just convert between the two. Why do we do this? Is because some people went with one way, one standard, the other ones went with the other standard. So now they decided to adopt a standard or a norm or they adapt new things that works with them, that work with them. Another example, before you get into hexadecimal, this table, when you look at it, it starts being confusing, but to me, it's my timetable for week 2. Okay, there you have week 2 there, the dates, okay, the days, and then the dates, and then the classes and the periods. Okay, period 1 I have 9v ct1. If you don't know this, you wouldn't understand it, but for me, I understand it, and I made it shorter because it suits me this way, because I have less space to to write everything. So in a small short box, I have to write 9cv ct1 cs1. It could have been year 9 violet computer and technology 1 cs1, the classroom cs1. So that would be too long. Okay, that would have been very, very long. So now we use these things everywhere. Have a look at this now. Have a look at this bin. What does it do? Now when you hover, because human beings develop, evolve. So when you hover, you have a title, you have something that shows what it does. Okay, so if you go here, it's a new slide. If you come, we wouldn't know what's this. Okay, but now you know, reuse slides. You can reuse slides. You can have here a slide layout. So all these icons and everything you see, the emojis, everything is for human beings to adapt. So things gets easier. So we don't have so much writing here. Imagine if we had text for every piece of menu that we have on this bar. We would not have enough space. So you have this here meaning the colors, the shapes, and so on. Okay, so don't overthink anything. The hexadecimal is a system used to help developers, programmers, computer programmers. Okay, we will look into it. So now this is what we did this before. So this is just a starter to get you going. Okay, so we had to convert the first the binary to denary, then the denary into binary, then add the two together. So the binary to denary, we would add every value from this list here, from this name values, every value with a 1 in it. So if there is a 1, there is existence. If there is a 0, there is no existence. So the 1 to 8 it exists, but the 64 doesn't. Then the 32 exists, then the 16 does, and the 8 and the 4. So if we add everything together, that would be, we have here 40 plus 20, that's 60, and 128, that's 188. 188. Okay, so we have our conversion. That's as simple as that. Okay, now the second one, the 11, the 11 is the total now, and nothing above the total should be added. So we can't add 1 to 8 is because it's above the total, is more than the total. With the total, the maximum we can have is 11. So now 64 the same is too much, 32 is too much, 16 is too much, 8 is the first one that is below 11. So we put 8. 8 we have a 1, then 11 minus 8 is 3. 4 is above 3, 4 is more than 3, so we won't put it. Then 2 is within the total 3, so we put 1, and then the remainder, when we deduct 2 from 3, the remainder is 1. And then, so that's why we have 1, 1. 1, so which means 1 plus 2 is 3. They exist, both of them exist. Now to add the 2, 0 plus 1, we have a 1. And this is the method, and this is the rule. These are the rules. They're not changing, okay? They won't change. If you understand them, you'd be happy. You'd be good, and then you can carry on, and then you can do many things. 0 plus 1 is again 1. 1 plus 0 is 1. 1 plus 1 is now. 1 plus 1 is 1, 0 in binary. 1 plus 1 is 1, 0, which indicates the number 2, which is the representation of 2 in binary. So 1 plus 1 is 10, is 1, 0. So we put the 0 and we carry the 1 as we do in our decimal calculations. We carry the 1. So we would have 1 plus the 1 we carried. So then again it would be 0. And then we carry the 1. So we'd have again 1 plus 1. So it would be 0. Instead of 10, we said it would be 0. And we carry the 1 here. So then we'll have 1 plus 0, it's 1. And then 1 plus 0 is another 1. So when we count everything together, all of this is 199. You can verify both ways. So 128 plus 1 plus 64 is 192. 192 plus 4 is 196. 196 plus 2 is 198. 198 plus 2 is 199. So you can verify 188 plus 11 is 199. So you have the correct number. Okay, these are the results. So let's tackle the hexadecimal values or the hexadecimal system. The hexadecimal system is a way of counting that uses 16 digits instead of the 10 digits we are used to. We are used to these digits here, 0 all the way to 9. Okay, we are used to these ones. Let's put them in a different color. We are used to these ones. Okay, but then to make things easier for programmers, from 10 to 15 we started representing them by letters. From 10 to 15 we started using letters instead of the 10, 11, 12, 13, 14, 15. So instead of those we have A, B, C, D, E, F. So then the hexadecimal will include 0 and then all the way to 9. Then we go A, B, C, D, E, F instead of 10, 11. The reason, I'll tell you the reason. The reason for this is that we use the hexadecimal system in computing to make it easier to read and write big numbers. Now just imagine if I asked you to write this in binary, or if I asked the best programmer to write this in binary. Each letter would have 8 bits, okay? So imagine that 8 bits plus 8 bits plus, you will be lots of zeros and ones. So the hexadecimal is like a shortcut for programmers and engineers to work with big numbers without writing long strings of ones and zeros. No one would remember. Even if you have it written down, you wouldn't be able to copy it on the screen. So how, the question is, because now this hexadecimal is like a bridge between the binary and the humans, okay, between computer and humans. The computer understands zeros and ones. We understand denary and hexadecimal denary, but denary would be also too long. If we started using 10 and 11 and 12, it would be complicated. So to simplify it, we came up with the hexadecimal. I say we, humans, came up with the hexadecimal numbers, okay, to simplify things and make numbers shorter. So the question is to be asked, never be confused. The table will remain the same. This table will remain the same, okay? So the table here again will remain the same. The question is, how do we convert? We need to learn how to convert between binary number and hexadecimal number. So how do we do that? Now you have a binary number, okay, a random binary number, and we want to convert it to hexadecimal. So step 1, this is the method. Once you understand the method, it's like doing the multiplication table. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and so on. So step 2, so step 1, we split the binary digits into groups of 4. So we have our groups of 4. Now step 2, we add zeros, okay, to the leftmost group if it has only 2 bits, okay. So now this one had only 2 bits. We have to add 0 0 just to make it 4 bits to go with the method. So now the binary number is split into nibbles. That's what we call nibbles. Each 4 digits are called a nibble. 8 digits are called a byte. Remember this. You can stop the video, go back, and then you can easily remember it if you hear it once, twice. So now we have our binary number ready for conversion. So now the step 3, convert each nibble to its equivalent hexadecimal number. So the first one would be the leftmost one. Let's see what it gives us. Well, I don't need to this was in class. So now 0010, let's have a look. 0010 is the number 2, so it's equal to. Then 1110 is the E, or 14, and we don't want 14 because we'll be having 214, then 214 and 15. It will be too much. So now we know it's an E, it's 14, it's an E. And then we go again and look for 1100. 1100, 1100 is a C. 1100 is a C, then 1010 is an A. So we could say now that our binary number, however long it is, this one, is equal to 2ECA. 2ECA. So that's our binary number. We converted. That's how easy it is to convert a binary number into hexadecimal. You divide it into groups of 4, add the zeros at the leftmost to make sure the left one is also 4 digits, and then you look at the table and convert your binary to hexadecimal according to the table you have. I'm gonna skip the video, but you can watch it. It's in the homework. What I'm gonna do is I will let me escape this. I will model for you now how it's done. Okay, how it's done. Let's say now we have the number 1 1 1 1, and then 0 1 1 and 0. Not there, but here 0. So now I want to tell you something. Once we divide into nibbles, we will forget the place values we had already, and then we will change the place values into something else. Each nibble will be a maximum of 8. Okay, each place value now will have a maximum of 8. Let's have a look. 1 2. Again, this is done because it helps, with the counting, and it avoids complications. So this is now our new place values. These are our new place values. If you want to be fancy and start playing with these colors, as you can see, I manipulate PowerPoint as well. You're learning to work with PowerPoint. Now, always have an open mind. Always have an open mind. So now, 1 1 1 1 1 is 15, okay, which is F. Here you go. And then 0 1 1 0, we count this as, let's have a look, 0 1 1 0. In here you go. In hexadecimal, it's the number 6. So we have 6. Okay. If we wanted to count the binary and convert it into denary, all we need to do is count the place values with 1 underneath them. So let's try again from scratch. 1 to 8 plus 64 plus 32. No. Sorry. Plus, let's see if it works now. Plus 16 plus 4. Everything with the 1 in it means is there to count, okay, to add. Plus 2 equal 246. So in denary, that's 246. So that's one binary number converted in hexadecimal, and then into denary. So let's say if we had now if we had another hexadecimal, another denary this time, let's say a denary of 248. Can we do 248? Let's have a look. Why not? We try. 248. We calculate. We convert 248 to binary. Okay. So now we will have 1, and then 200. Let's count with the calculator. So then the total is 248. So 128. 248 is our total now. 248 minus 128 equal, so 120. So again we can have a 1 here, and then again 120 minus 120, yes, 120 minus 64. So now 120 becomes our total, and 64 is the one we deduct from. So now we're left with 56. Do we have 32 in 56? Yes, we do. Okay, so now 56 minus 32 equal 24. Okay, so we have 16 within 24. So 24 minus 16 is 8. So we have 8. And then we said 16. 16 minus 24 minus 16 is 8. And then so we have 8. 8 minus 8 is 0. So we will have 0, 0, and 0. Okay, let's count and verify. So now we have 128 plus 64 plus 32 plus 16 plus 8, and then plus, that's it, 0, and then plus 0 plus 0 plus 0. Okay, so now we have our 148. Let's convert it now into hexadecimal. So now we do the nibbles. Okay, we have our 2 nibbles. So 1111. You look at the table. What is 1111? Is there? Is F? Is the letter F? And 1000 is 8. Is 8. So when you look at it now, you have F6, and then you should have F7, F8. That's 246. We should have here 247, and then 248. So that verifies. Okay, that verifies. Where is hexadecimal used? Where is the hexadecimal used? It's used with colors. Okay, it's used with colors because color picker, and it's used with, is there, can you see? This is our hexadecimal number, because we avoid all the ones and zeros, and it's used in different places in computing, in lots of fields of computing. I think I'm done. It's used, let's say, it's used in the MAC addresses, in the new IP addresses, because they have so long numbers. So now what I'm gonna do is I'm gonna fill this in partially, and I'll let you practice and try it yourselves. Okay, so I think I'm done. Oh, sorry. I will stop this video now, and I'll catch you next time. You take care. Bye.